We are going to simply speedrun Nandgame, and this is my run. This actually is an Nandgame. This one has like an invert when the in is is always one, and therefore an inverter, since the NAND is just the same thing as an invert, the NOT gate, but with two inputs, we can just simply do this, and it will flip the bit. Next is an next is an AND gate, and we need to quickly put this down here, since NAND plus in like N something plus invert, which is just NAND again, but just like, invert is just not. It's called not. It has always been called not. I don't know why this calls it invert. That's not very helpful. The game even acknowledges that. But I need to. XOR. I remember the solution. I remember the solution. The solution was found from GitHub. It's not very. Okay, I'm gonna switch. Okay, I'm gonna switch. I'm gonna switch to my finger. Ladder. So it is possible to solve this with a lower total. However, this is I will not always do the optimal solution. Most of these solutions have been found outside of the normal NAND game. But if you want to check out any of these solutions, you could go to GitHub. I just want, well, I don't use GitHub to try to cheat or anything. I just use it to try to confirm. This component is helpful. Times 0 minus 0 is not this. So we need, so, yes, we just take, we invert, well, 0 doesn't actually contain any logic, so we don't actually need it here. Right. Output must be connected to some sort of input. To check if any of the many inputs is on, we need to make an OR game tree, which requires which I am not speedrunning every single level in this game. I'm just gonna speedrun the main track, so only all of this. Sincere. Choose complement makes a 15-bit the sign, so therefore that means that it's like this. So now it's a selector. So yeah, very much. The imply. The imply gate is just this combined. So this is not the minimum, but like switch will just, yeah, switch is just kind of easy. Simple. It's just the same two tracks as before, but they're separated. I might switch from my mouse to my finger instead. Sometimes because like sometimes it's faster. Select 16 pyramid. Oh. Well, since both of these have to be off for and, that means that means it will go with this, and by transitivity we can figure out that. And we'll simply by looking at the rules because we will have eyes. This, except for this. This is an issue because now the solution is not valid. Zero, zero for and. So yeah, Nandgame can decide to do this to you, but it's pretty simple. If you can't see the overlapping wires, it's just simple. You just but add and sub, instead of having to do all of that, you can actually make them share the same thing. I learned this from GitHub. I mean, like, but if it's there, then we can just use, basically if it's there, then we can, but basically but if OP0 is here, then we should set the B value to 1. So instead, what we would do is we would just take a little invert, which will serve as a 1. You can see that right there. It's a 1. It's a 1! So, yeah, we can actually just use this for this. Simplest possible solution. So yeah. ALU. This one is, other people mostly will tap out, but this time is pretty nice. The U will be the switcher for this, and since logic comes after arithmetic well, logic comes after like math, like actually like trying to figure math for some reason. It's not really accurate, but I mean, like, but I learned the solution. This is the X. 0, OP0, and OP1. Like, but you'd think that I'd use multiple limbs, but actually, no, I can't do that. But, yeah. Should these guys if S will have his foot. And from that we have, but if we just say make this 32, which is 10 and 20. Actually, this one is actually the y value, and the x value, well, it could be this. Right, I don't remember. No, of course I remember. Why wouldn't I remember? Of course I would remember. Why wouldn't I remember? Condition. Also, this, to be clear, this is not an I, this is an L. This says LT. It's just that the font is messed up is just messed up in that regard. But serves like a junction, kinda. Not really though. Say that's 1. Well, then it's greater. This is probably not the optimal solution, but yeah, we are going pretty far in. I know this is not world record based, okay. I just, well, using negative gates here doesn't seem like a sensible thing, and it is not by a long shot, but I mean, like, but this one is fundamentally broken. This one is fundamentally broken, though, so. Wait, why am I fishing around this? D-latch is literally just, it's literally just if store, then sit, then this one. This is a data flip-flop. Doesn't require a lot. Register is a 16 bits. It's just like the number of bits in your microprocessor. The number this that will be the STCL, and well, there's one of each, but there also is the number of bits that you're wanting to store the number of D's. D as in data. But since we are building a 16-bit computer, it's based on NAND transfers, so we will have a 16-bit unit. This is called a register. That might sound familiar, and it is familiar. However, it is a basic memory component and not actually the highest one that people have invented thoroughly. So yeah. Yeah, this is not this. Yeah, this is not the correct solution. I had to take a quick break, so yeah. But basically, yeah, simple invert. The reason why there's a cut in the footage is because of the fact that I had to go take a break, but but that timing doesn't count since I wasn't well here. So yeah. Anyways, this is random access memory, which is RAM. Yes, this is what we're actually doing. So we need two registers and we need a switch. The address is the S and the ST is the data. CL and X are still the same, but it won't even matter if they don't get the correct storing signal. This is register 1 and this is register 0. So therefore, and now yep, we just select based on the address from the beginning. And it matches. It matches. Combined memory. So we have two registers A and D, and one RAM bank, which is A star, which the address is the A register. So combining the RAM, our random access memory that yes has the actual store 64K values. Anyways, let's just keep on going. Let's keep on going. Reason, I mean, I haven't played this in a while, but we're only speedrunning the hardware part. Software will be another time. But I probably won't speedrun the software on camera because it is seriously hard and not fun at all. But once again, go to github.io for if you want a solution. But actually, ALU instruction is not easy either. This combines everything we already know. So the condition is actually J, so we can call it that by association directly. As explained at the site here, you can pause and read it because you literally have a pause button right on the screen. Anyways, yes, we will have to completely not. I feel like I don't actually feel like I'm actually speedrunning, but it's not. It doesn't feel like a speedrun attempt at all, and that's because it's not. I'm not really trying to speedrun. You can't even see the timer because there is no timer. But if but you can check at the video description. So the X input should be the and the depending on if bit 12 is in the instructions. So if bit 12 is 0, then it is an A, and by that extension v1 equals A star. So the JFlag will condition specs conforms to this specification the LU output, which are right. This is not correct, and the reason why for that is it's because we forgot what. Now we're going on to control selector. This is just a gigantic selector for a bunch of different for basically the ADA star and the JR with an S, which in the end some of the circuitry won't even matter because of the fact that there's a little secret, because later on that's not very useful. I know my strategies are suboptimal, but at least you at least give this video a like. This is gonna be raw. This is gonna be like raw edited footage. Like, you could literally see how it was like glitching into the for a split second. Anyways, you go R A T A star J, and then we take this and if in this that then this data instruction. It's one, then it's one, then it'll be all of this will be pouring in, but otherwise but for data instruction the output R should be the I input and the A should be 1 and all the others will be 0. 0 never matters. I mean like the possible numbering of 0 does matter, but like the actual thing right here does not. And thankfully doesn't count towards our NAND count. So this is not a confirmed solution. However, people have been trying to confirm it for a long time. Also, no, the green circle does not speed up. This is finally everything. Come on. Sorry, I had to yawn. But, yeah, pretty much. Clock is the clock signal. Wait, I have to, oh, wait, I have to go just right. Okay, so, I'm back. Counter is most likely address. This is most likely I, and the 88, all the 88 like parts are all going to be cycled, but now the X here is supposed to, well, actually the J here is supposed to be the did not mean to do that. Anyways, the store signal is probably J, and the X signal is R. One more thing, the X is A from the 88 from the memory. And this is the simplest possible solution. So now we will go on to this, the input and output, the final level in this run. So I know I'm not on record pace, but am I the first person to speedrun this specific track? Probably not, but at least I feel accomplished. That's what matters at the end, right? I know I sound so corny right now. No one's probably even watching. Transparency. There's no transparency, because at least there is no okay, listen. By transparent, I meant this light, this lamp. Doesn't look like a lamp at all. But it is. And by transparent, I mean, yes, the government is not transparent at all, but I mean, and this is the speedrun done. So yeah. And this is the simplest possible solution. So if you guys want to see assembler, then yeah, like the video. But until then, I'll see you guys next in transistor levels and and functional complete. So these two are next. Bye.